Kepler 138c, Kepler 138 Charlie. I like Charlie better, I like the name Charlie. Establishment dogma has this star, not exoplanet, obviously. In the theory of stellar metamorphosis, all stars are new planets, and planets are actually ancient evolving stars. Kepler 138 Charlie has a homogeneous ball of gas with zero differentiation. We know this because what they say Kepler 138 Charlie is a mini gas giant as per the Wikipedia page. Meaning this is uninteresting, it's not doing anything, it's just an inert ball of gas which they try to mathematically model. That meaning that they're ignoring all of stellar evolution right off the bat. It shows their mentality for what it is that they're looking at. Just place it in a little box, this is what it is, and then brush it off and go try to find something else. I think what leads to that mentality is the fact that a lot of those people using the telescopes, they say, well, you know, I want to be the first to discover this one or discover that one. Well, this object was already discovered. So all the astronomers, they go out and look for another thing to discover because they want to put their name by it. They want to have their ego supported by a discovery of a new object. So here the object is homogeneous ball of gas, and then the astronomers, they go somewhere else because they're bored with it. But this is not a boring object. They say its density is too low for it to be a rocky planet. Unfortunately, this is absolutely horrendous reasoning because you can explain the density of the object. Sure, it's not that dense when you consider the entire thing, but you can have a large object in its center, such as an Earth-sized object, which is rocky and metal in structure. And then you can have a thick atmosphere, meaning it will be a lot less dense than an Earth-like body, which is mostly rocky in nature. But what it also means is that it has a very thick atmosphere, okay? Meaning the atmosphere will probably stretch out here to right here. A very, very thick atmosphere, probably many, many miles deep in water vapor, methane, various other chemicals and chemical compounds and such. And the study of how and why this is would be pneumatics or air compression. If you have a very low density area right here, and supposedly it's gas, well, it's going to go up in compression regardless, because the gas will compress under a lot of pressure from gravitation. Meaning there's probably a large rocky core in the center there. And what we're looking at when we see Kepler 138 Charlie is an intermediate stage in star evolution between Neptune and Earth. Let me go ahead and draw a quick diagram. Oops, should have erased the name. Kepler 138 Charlie, okay. Now, with basic star evolution, on late stages, you would have, say, a Neptune-sized object where it has the core in the center, which is the newly forming planet, and all the materials depositing on it, making land, cooling down, all that good stuff. And then you have Kepler 138 Charlie. Has shrunken considerably, yet the core of the object has remained relatively the same size, and the material still depositing into the center. And even more time goes by, and the star takes up orbit around a hotter, younger ghost star, such as the Sun. What happens is that atmosphere gets ripped away, and eventually what you have is that same size, a little bit bigger, rocky ball in the center with a thin atmosphere. And that is the essence of Kepler 138 Charlie. Sure, it is a mini gas giant per establishment dogma, but what they forget is that as the gas giant is evolving, it is taking that gas, depositing it into the center of the star, forming the new planet. And as it ages, that central structure gets larger and larger, and the atmosphere dissipates away. Obviously, there's much more work to do regarding this, but I just wanted to point that out to the reader, that you can tell what the mindset is of these supposed scientists that work in establishment astronomy. They don't want to look at these objects as being dynamic in nature. Okay? This is a dynamic construct, okay? It changes. This shrinks, loses atmosphere, builds an interior gets bigger, atmosphere still dissipates, interior gets even bigger, atmosphere still dissipates. Establishment, they like static structures when it comes to star evolution or planet formation. They like to make everything poof, here's a planet, here's a star, no explanation for it whatsoever. Because they don't look at these objects as being dynamic. They have to fit them into mathematical models. And the mathematical models work the best when the structure is static, because that's what math is the best at, explaining static structure. One chair plus two chairs, or one chair plus one chair equals two chairs. There's no motion in it whatsoever, it's just a static concept. So basically that really sums up Kepler 138 Charlie. I suggest you look it up yourself. I will link the paper that I've written this on below. I think I wrote this paper about 2 years ago. Hang on, let me look at it. No, not 2 years ago, June 15th, 2014. But I just noticed that huge problem with their modeling of stellar evolution. I will also have to make another video overviewing more root assumptions, things they've taken to be true that are absolutely false and that are leading them in the wrong direction. Kind of like, I don't know, a dead end type thing for them. And, unfortunately, you know, there's only so much you can do to teach them how things actually work. So, you know, it's up to them if they want to really, you know, step outside of their comfort zone. You know, you can't make people learn new things. They have to choose to do that on their own. All right. Oh yeah, today is May 21st, 2015.